All right, so I think this is recording. Let's take a look at these two quadratic inequalities and see if we can solve them. Um, our first step is to get this in standard form, and on the left-hand side it is, and to ignore the inequality and to just write it as an equation. So I'm going to look at x squared plus x plus 1 is equal to 0. And now, unfortunately, here I cannot factor that, so I'm going to have to use the quadratic formula to solve this. And I'm going to find the discriminant first. Remember, the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac, but this b squared minus 4ac is the discriminant, and oftentimes there is an advantage to finding that number first because it tells us immediately what to expect on the number and the type of solutions to this quadratic equation. So if we identify A, B, and C, which A is 1, B is 1, and C is 1, and this discriminant b squared minus 4ac, the number that's underneath this radical, b squared is 1 because 1 times 1 is 1, minus 4 times a times c, and this is 1 minus 4, which is a negative 3. All right, so there's no way that this quadratic equation will ever equal 0. So we know that there's no solution to my original equation. But I have to be careful. That's not my final answer for this problem. I have to interpret what that means in terms of a graph of a parabola. Remember that x squared plus x plus 1 is a parabola. And we know what the graph looks like. We know that parabolas are U-shaped that either open upward or downward, depending upon whether A is positive or negative. I know that this parabola, this quadratic equation, x squared plus x plus 1, opens upward. And since there's no value of x, there's no point on this parabola that will have a y-coordinate that's 0. So here's the x-axis. What do you know about all of the points on the x-axis? All of the points on the x-axis in a two-dimensional plane have a y-coordinate at 0, because if you're on the x-axis, you haven't gone up or down. So this whole parabola lies above the x-axis. Now, let's look at the original inequality. It says for what values of x will x squared plus x plus 1 be greater than or equal to 0? Well, for all values of x, for all real numbers. All real numbers, any number that you pick on this number line is going to result in a number that's positive. It's never going to be 0. It's never going to be negative. It is going to be a positive number. It is going to be above the x-axis. Our solution set to this inequality is all real numbers, from negative infinity out to positive infinity. So I hope that helps on that one. Let's look at this next one. All right, so again, this is in standard form. I don't want to look at the inequality yet. I want to look at an equation. I want to look at x squared minus 3x minus 10 is equal to 0. Now this time I can look at these numbers and I believe that this is going to factor. It's easier to see in your head that it's going to factor when that leading coefficient is 1. However, if you still prefer to do the x method, you can go over to the side and do that. But what will you discover? Well, you'll discover that x times x gets you the x squared. And two numbers that multiply together to give us a negative 10, one of them is going to be a negative number and the other is going to be a positive number to have that product be negative. And the larger one in magnitude is going to be a negative. Well, 5 and 2, only we'll make the 5 negative and we'll make the 2 positive. And negative 5 times a positive 2 is negative 10. And when you add these together, you get a negative 3. So that's how this factors. This separates into two equations where x minus 5 is equal to 0 or that x plus 2 is equal to 0. Now, most of the time, I don't take the time and effort to really write that. I just simply look at this and say, well, that 5 minus 5 gives me a 0, and negative 2 plus a positive 2 gives me 0. So by inspection, we look at this and say that 5 and negative 2 are our two answers. Well, let's put those 2 points on a number line on the x-axis. We've got negative 2 over here. We've got positive 5 to the right. If we look up at the original problem, it was strictly less than. So I know that I'm going to leave these as hollow points, and I'm not going to include them in my solution set. If I look at the leading coefficient here in front of this x squared, it's positive, which means that I have a parabola that opens upward. So I know that the graph of this thing on the x-axis has x-intercepts of negative 2 and positive 5. Now I want the values of x that will make this arithmetic, the output of this, the y-coordinate, be less than 0. That's going to happen if you're between these two values. Pick any number that's between negative 2 and positive 5 and plug it in and do that arithmetic, and I guarantee you that the output, that the y-coordinate, is going to be less than 0. It's going to be below the x-axis. All of these infinitely many points that are between negative 2 and positive, all of these points on the parabola have an x-coordinate that's between negative 2 and positive 5, and all of these points have a y-coordinate that's negative. If you look at these other points up here, all of their y-coordinates are positive, and the ones on the x-axis have a y-coordinate of 0. We want this to be strictly less than 0. So we want our solution set to be bigger than negative 2, but at the same time smaller than positive 5. Remember, it's always a smaller number, comma, a larger number when you're writing these inequalities. So, hey, we're done with these two, and I hope that helps. If you have any questions, don't be afraid to ask, or ask other students and stuff. Work together on this. You have to ask questions. No one looks at this and understands it the very first time they see it. So, hey, I'll talk to you later. Hope that helps. Bye.